We are going on without CBC introduction of autoencoders. Unit 5 autoencoders in offering. What is autoencoders? In supervised learning, it uses explicit label or correction output in order to train the network. That is the supervised learning. Example classification of images we can see. Unsupervised learning relies on data only. Example, C bound, unskipped gram, word embedding. Key points is to produce useful embedding of words. The embedding encode structure, such as word similarity and some relationship. This is the example for unsupervised learning. Do you know what is supervised learning and unsupervised learning? Now, what's auto? Yeah, exactly. The autoencoder designed to reproduce their input, especially for image processing. Key points is to produce the input from the learned input. Okay, just compare PCA. PCA takes collection of vector. Already I said PCA mainly it takes all the vector set and reduces the vector set and extract the features set. PCA takes collection of vector that is the images and produces usually smaller set of vector dimensional projections in PCA. Very efficient for certain application. Fourier and wavelet compression like that. But autoencoded individuals can learn nonlinear dependencies. It can be used for convolutional layer or it can be used for transfer learning. These areas we can use autoencoders. See the structure of autoencoder. We have an encoder and decoder, right? Yes. You see the image, we have a original input and it is inserted into the encoder unit. Then the encoder compressed into the latent space. Latent space, usually smaller dimension, h equal to f of x. Then decoder unit reconstruct the input from the latent space r equal to g of x. Reconstruction mode. Encoder, compression, decoder, reconstruction. Then reconstruct output we can see. So this is the structure of autoencoder. Then application. In which application we can apply autoencoders? Yes. One of the applications is denoising. We can clean the image plus noise and train to reproduce the clean image. Okay. So this is the noisy input we are given to the encoder. Encoder compress the image and it is creating the latent features. From the latent features, decoder decodes the image and it is splitting the noise and reproduces the clean image. So denoising, image denoising, that application we can use autoencoders. Another application is image colorization. Black and white image. So the black and white images colored, transferred into colored image. In watermark removal, we can use autoencoder, watermark removal. Then what are the properties of autoencoder? So there are three properties. There are specific, lossy, learned automatically from example. So autoencoder or data specific. It compress the data, similar data, and the lossy, decompress the output, will be degraded compared to the original input, then learned automatically from the example. These three properties are particularly for autoencoders. Capacity. Autoencoder addresses capacity. It's a combination of bottleneck layer, training to denoise, sparsity through visualization, and contractive chronality. So capacity, most things a problem when capacity is too large. Otherwise, it is not a big deal. Bottleneck layer. Suppose we have an input image n cross n and the latent space is m less than or equal to n cross n. The latent space is not sufficient to reproduce all images because it is lesser than the original image. needs to learn an encoding that captures the important features in training data. So if it is not sufficient, then we need to learn the encoding that captures the input features in training data sufficient for approximate reconstruction. This is what we got left out. And simple bottleneck layer in Keras, that is for your understanding purpose. 28 plus 28 images into 32 times 2 value. When denoising autoencoder, basic autoencoder tries to minimize the loss between X and reconstruction and the reconstructed image, the G of f of X. Denoising autoencoder trying to minimize the loss between X and G of f of X plus W, where W is the random noise. So basic autoencoder just reconstruction. Here, reconstruction and minimize the loss. That is random noise. Same possible picture on different training data. Basic autoencoder and denoising autoencoder. So denoising autoencoder cannot simply memorize the input-output relationship. The denoising autoencoder learns a projection from a neighborhood of training data back at the training data. It is not simply memorizing input relationship. That is denoising autoencoder. Since mass autoencoder construct a loss function to penalize activation within the layer. It regularizes the weight of a network, not the activations. Their individual nodes of trained model that activate or data dependent and selectively activate region of network depending upon the input data. These are the features of sparse autoencoder. We have different kind of autoencoders. In sparse autoencoders, we can construct a loss function, penalize the activation. One is L1 regularization, then KL divergence. L1 regularization penalize the absolute value of the vector of activation A in a layer H for observation I. KL divergence use cross entropy between average activation and desired activation. So this is sparse autoencoder. Then contractive autoencoder. It arranges for similar inputs to have similar activation. Then denoising autoencoder make the reconstruction function. This is small permutation of inputs. Then contractive autoencoders makes feature extraction function. Okay. So mainly contractive autoencoder used for feature extraction function. The contractive autoencoder makes the feature extraction function. See the image and understand how the encoder contractive encoder feature extraction is done. That's all about the autoencoders. Both the denoising, the contractive autoencoders, both are performing well compared to basic autoencoders and mass autoencoders. So just recall all the points about the autoencoders. So autoencoders, classification of images and unsupervised learning, both the areas we can apply autoencoder. Autoencoder consists of encoding unit and the latent space and the decoding. So while compared to the PCA, autoencoders use non-linear dependencies, convolutional layer, and transfer learn. The encoder unit compress the input data into latent space, decoder reconstruct the input of the latent space. Then denoising application, denoising and image colorization, watermark removal. These are some applications of autoencoders. Then properties, data specific, lossy, learned automatically. For example, these are the properties of autoencoder. Then what is the capacity? Capacity is very important. The fitting, overfitting is a problem when capacity is too large. Then bottleneck layer, training to denoise, sparsity, then contracting value. These are the then bottleneck layer, already we seen bottleneck, what's bottleneck? Then simple bottleneck on Keras, then denoising autoencoder, now it reflects. Then sparse autoencoder, then contractive autoencoder. That's all. So after this, We have learned the basics of autoencoder. So next class, we go in deeper to the autoencoders, then how the PCA, principal components, is transferred into the autoencoder, PCA to autoencoder. That we'll see in the next class. So thank you. Thank you, Onam.